Continuing our lecture, we already talked about this slide. So high cohesion. We aim for high cohesion. High cohesion makes it easier to understand what a class or method does, descriptive names for variables and method classes, and reuse of class and methods. So in other words, if you've written your code right, you'll be able to go through and reuse what's in your system effectively over and over and over again. The names of variables, methods, and classes just make sense. When you read them, you know what they are. For example, string. String is a string. There's no doubt. There's no question. If you look at the parse or you look at the other methods, they do exactly what it is that they say that they're going to do. String is not named XYZ. What does that mean? Nothing. I would be confused if I was a developer and I suddenly used a type called XYZ. That means nothing to me. Have it as house, home, street. Things like that are descriptive names that people understand and can work with. They should be self-describing, it's called. That's very key, unbelievably important. We aim for loose cohesion. Methods perform multiple tasks. In other words, we're trying to not have things do everything. You don't want to have classes modeling multiple entries. You don't want to have clear identity, or these are all the be carefuls of, unrelated packages and classes. So avoid this stuff. Don't do that if you can. Single purpose, responsibility driven design is very important. Cohesion applied at different levels. You should have cohesion at the class level. A class should represent one single well-defined entity. In other words, it should do one and only one thing, and that thing shouldn't be too huge or too granular. The right answer oftentimes comes from your design or your architecture standards, and you should refer to your development leads, or if you are the development lead, you need to think about what is too big or too small. You don't want classes with millions of lines of code. At the method level, methods should be responsible for one and only one well-defined task. In other words, the method shouldn't do everything. You don't want a really big class with only a single method in it that does everything under the sun. Don't artificially break it up. Don't have A calls B calls C, and it's really just one long thing. You haven't helped anything that way. Module package level, groups of related classes. So in other words, when you're doing a package, packages should have like things. So for array list, everything related to array list is in that one package. They don't have it in 5 different places, and they don't have random spurious things like random isn't part of array list, as an example. Code duplication. A good indicator that you're making a mistake is when you start seeing code show up in multiple places that does the same thing. Now, I will tell you that an if statement kind of breaks that rule. You might have to check for the same condition over and over and over again, because in between each if statement is code that is generic and handles everything, but in certain places you need to have an if statement for specific conditions for that 1 or 2 or 10 lines of code. That's okay, but when it happens too much, you need to start looking at that and think about if your code is structured properly. And if you can consolidate all those ifs, then you start to see about if you should break those out into different classes. Let's see, can lead to the introduction of inconsistencies. So in other words, when you have code duplication all over the place, suddenly somebody puts an exclamation mark, meaning not in front of a condition, and you get a weird result. Or what they're really talking about is if code is in multiple different places, somebody modifies it in 2 places and forgets the third, suddenly 2 classes work properly, the third one doesn't, and nobody can figure out why. And code duplication can happen at the class level and at the method level. Can't tell you the number of shops I've gone into where they actually have 5 versions of the same method or of the same class, all called something differently because they had bad documentation, they didn't have good knowledge transfer, and as people came on board, everybody assumed that it wasn't done because the system was so big and so poorly documented they couldn't figure it out. Thinking ahead, spend the time. I've talked about it multiple times in these lectures. 90% of your effort should go into the requirements and the design. If you're doing this right, you will spend more time on that and less time coding, mainly because of the efficiencies you gain because you did it once right. You aim to make those changes easy. In other words, if you've designed it and thought it through, you know exactly where to go and you're not what-ifing your way through the code. What if is a lazy developer's way of getting through this, and it happens more than you can imagine. Everybody says they won't do it, and then you just lose your energy, or you lose your excitement, and you start what-ifing to see if code works, or especially if you get frustrated, which may happen to some of you in this class. It's not unusual to be nervous and not sure if you're going to make a deadline, so you just start trying ideas, and hopefully one of them will stick and work. Try to avoid that whenever you possibly can. You get smarter and you get more efficient code if you can stop, think about it, take that short break if you need to. requires a little more effort. In other words, if you work it now, you save effort later. Now, what they're talking about is in the world of development, you have this triangle-looking thing. And what happens is along the bottom line is time. So as time goes on, the amount of effort it takes to fix something increases. And a lot of people draw it as a straight line. It's actually more exponential, because when you start having to miss deadlines because you discovered something late minute because you didn't have a good design, that costs a lot of money, and it reduces confidence in you as a developer as well as your department. And ultimately, you need to protect each other and yourself against easily avoided mistakes. Refactoring. When you refactor classes, that's basically you're going back and you're fixing your code and you're making it better. After a certain point, you need to understand when you're going to stop refactoring and you're just going to simply rewrite. There's no right answer for this, but developers have a tendency to look at everyone else's code and assume that it's garbage and want to rewrite that class. Don't allow that to happen. Every now and then, classes should be refactored. Now, as you go through them, you look at cohesion, you look at load coupling, you make sure that you've done everything properly, and then you fix the classes based on your learnings and experience, because as much as you wish for it, you seldom know everything up front. Refactoring and testing. When refactoring code, separate the refactoring from making other changes. What usually happens is a developer goes in, they're aware of 5 other defects, and they want to go fix them all while they're there, and suddenly things break, you get unexpected releases, you have behavior change, you have upset users. Go in there with a laser pointer, do the work that you intended to do it when you intended to do it, and follow a line. If you want to add to your scope, talk to your development lead, the director, them whatever, to make sure that what you're doing is the right thing. First, do the refactoring only without changing functionality, then go back and do it. Where it talks here about test before and after refactoring, this is huge, hopefully using a concept called JUnit that we'll go through later. But the goal is that you make sure that your code is right before and right afterwards, and that only those things that you expected to change actually change, and that they change in the way that you expected. If you get a different result, then it means that your test cases are probably wrong and you need to go back and redo them. Or your code is completely wrong and you need to go back and fix your code. Common questions: how long should a class be? How long should a method be? There is no golden answer. It should be as long as it makes sense, as long as you can maintain cohesion and coupling, and that you don't get overly long. A rule of thumb I used to work with is a method should never be longer than 1 printed page. People don't print anymore, font sizes get messed up, so it's become less and less a valuable tool. But basically, if it's so long that you cannot understand what it's doing, it's too long. But sometimes you have to have a long method because there's no logical break in it, and you need to be honest with yourself as well as your architect to make sure that you're doing the right thing. Decide guidelines. If it's too long if it does more than one logical task. A class is too complex if it represents more than one logical entity. Very true statements. And when it makes sense, you want to reduce that, but you can't always do it. So these are guidelines, not rules. Alright, the last topic for this lecture is enumeration. Enum is a really cool class. It's very good for constants. It's an alternative using static int or static. I like it a lot. I think it's really cool. It's a placeholder for you. So instead of saying 0, 1, and 2, you can now say red, blue, and green if that's what you want to do. In this particular case, this is out of Zool, if I'm not mistaken. You have go, quit, help, unknown. These are all enums inside of command word. You can add new command words in here if you want to have extra commands. Okay? And then to reference them, you'd have command word.help, which is this one, and it would automatically stick that in. So now if you're accessing an array, list, or an array, you can literally get to it just by saying command word.help, and that will automatically represent the third position for you. It's pretty cool. And it's definitely a way to go. I don't see it all that often, but the people who use it and use it effectively, their code is much more readable. To review, programs are continuously changed. It's a fact of life. It is important to make this change possible because you want to maintain or handle new requirements and needs of the business. Quality of code requires much more than just performing correct at the one time. In other words, it needs to always perform, whether 1 row of data or 1,000,000 rows of data. It needs to perform. It needs to work. It needs to match your design. It needs to be refactored. It needs to be maintainable. There's lots of needs here. All of this is achievable through time and energy, thought, and careful progression on your development. Code must be understandable and maintainable using self-declared or self-defined or self-explaining Variable names and methods is one of the key ways. Following clear, consistent code styles and methodology is how you achieve that. Good quality avoids code duplication as a rule, displays high cohesion and low coupling. Coding style, commenting name is also important. Commenting, naming, layout, etc. is also important. That's back in the appendix. Very early on in this course, I suggest that you looked at the appendix to go through code style. If you haven't done that, this is a great time to do it. There's a big difference in the amount of work required to change poorly structured and well-structured code. If code is well-structured, you can usually go in there and change things at the finite small level. People who end up writing sloppy code or try to write really quick and they don't care about being efficient, it takes a lot longer to create to fix their code. I followed a developer early in my career. I ended up having to fix over 1,000 defects in 6 modules because they poorly coded, poorly structured, didn't design well, and I ended up having to fix that, so it caused me a lot of pain. Don't do that to your fellow developer. Do it once right and follow the rules. With that, that's the end of the lecture for Chapter 8. As always, if you have questions, please email me. I hope that you got something helpful and useful out of this lecture, and as always, talk to you soon.